In this lecture, you are going to understand about recursion and tail recursion. Actually, why to learn recursion? Because in the next lecture, you are going to understand about a function called as reduce, which is really important, by using which we can achieve a lot of transformation use cases. To understand reduce, how it works internally, we need to understand about recursion a bit. So what is recursion? Most of you might be knowing a function calling itself is called as a recursion. So let's assume that I want to print some 1 to 10 numbers on the console. How we do traditionally and how we can achieve the same thing using recursion, let me show you. Yep, you can see this Java code. I'm just showing it in Java, but this is a very generic one. So here I have a method called as print numbers, which is taking a number. So I'm iterating using a for loop here from I is equals to 1 till the number and printing it. This is a traditional way of printing numbers by using a for loop, but the same thing can be achieved using recursion. See what I am doing. I wrote another method which is taking a number. If number is not equals to 0, then I am again calling same function using number minus 1. So if suppose if I pass 10 not equals to 0, yes, it will call again print numbers and pass 9. Then again print 8, 7, 6, like that until it becomes 0. It will come, and finally once it becomes 0, it will start printing the numbers. So let me show you by running this code. I am calling from the main method print numbers up to 10. I am calling this method. Let us see how it works. Run as Java application. Yep, it printed from 1 to 10. I will show you one more example on how to print sum of numbers using recursion. See this carefully. Actually, I'll just show you in the presentation. What you can do is just see the algorithm if you are using recursion. I want to get a sum of the numbers present in this array. So sum of an array containing 1 to 4, right? It is nothing but 1 plus sum of the remaining. This is equivalent to, again, remove the first element, 1 plus 2 plus sum of the remaining. Again, this is equivalent to 1 plus 2 plus remove 3 and then sum of 4. Again, this is equivalent to 1 plus 2 plus 3 plus 4 and sum of empty array. So now sum of empty array, sum of elements in empty array is nothing but 0. Then we can go on computing in reverse order. We finally get 10, right? So normally using recursion, this is how we can call. You can write a function called as sum, which is taking an array or a list. Then remove the first element plus sum of remaining elements. Okay, sum of remaining elements 2, 3, 4 is nothing but equal to sum of 2 plus sum of 3, 4, right? So like that we can call same function in a recursive way. But if you know, in programming language, whenever you create some variables in a function, they are local variables, right? Local variables will be stored on stack by the operating system, right? So when we are calling sum with 1, 2, 3, 4 array, whatever local variables are there in that function, they will be placed on the stack. And then we are again calling sum of the array which contains 2, 3, 4. So whatever local variables are there, when second time the function is called, they will be kept on top of stack. Like that, on stack, all the local variables when you call will be stored. Then what happens? after the sum of empty array is 0, right? It will return whatever is on the top of the stack will be popped up like that. When you go down, the stack will become again empty slowly. Normally, whenever you are writing a function using a recursion, stack will be populated with all the local variable values. Keep this in mind. Now let me show you the logic of how to do that. Okay, so let me show you. You can see this code. I have written a method called as sum, which will take list of integers, numbers. So if the list is empty, I just want to return 0 because in the list there are no numbers, so it will return 0. Else I am removing the 0th element, that means the first element, getting it, and returning what? First number plus sum of the numbers. Actually, numbers that remove will remove it from the list. Sum of remaining numbers. This is what I wrote. Now in the main method, I created a list of numbers from 1 to 10 and I'm calling sum of that list. Let us see. 1 to 10 is nothing but 55, right? Sum of 1 to 10. Let us see. I'll just run this as Java application. You can see sum is equals to 55. So actually, whenever this sum is called, this method is called, if there are any local variables inside this method, the local variables will be actually stored on top of the stack, right? So like that, it may be possible. Suppose if I'm calculating sum of a list which contains millions of numbers, it is possible that stack may overflow, right? So to avoid that stack overflow, there is one technique. What is that? Whenever you are calling same method again, if the method call is the last line and there is no other code in the last line, then nothing will be stored on the stack because there is nothing to execute after this, right? So what, there will be nothing stored on stack. This is the idea. So at the end of the method, if you are calling same method again, nothing will be stored on the stack because after this method call there is nothing to execute. So if you are calling the same method at the end, last line, this is called as tail recursion, right? So now let us see how to write this sum method with tail recursion. You can see, I'll show you in this example here. Yep. First see this method. What I am doing, this method is taking list of numbers and I am passing a variable called as accumulator, which will be 0 initially. See, I am calling this method with 0. I'll pass 0. If the list is empty, it will return the value of accumulator. Suppose the list is containing 10 numbers, this condition will not be satisfied. Yes. Then what I am doing, I am getting the first element from the list and adding the first number to the accumulator. Then removing first element from the list. And now I am calling the same method with the value of accumulator. So this method call is a last line. So nothing will be stored on the stack, right? So let me explain it in this diagram. You can see for the first time when sum method is called, the accumulator value was 0. In recursion, when it is called again, first element is removed, accumulator will become 1. Second time again when it is called in recursion, first element is removed, now it is sum of 3, 4 and 2 first element plus the earlier accumulator 1, 3. Again this when it is called in recursion, it will become sum of last element 4 and 3 plus 3, the existing accumulator first plus first element. Then again this will become sum of empty list and 6 plus 4 10. And here the logic says if the list is empty, return the accumulator. What is the accumulator value at the end? 10. So it will return 10, right? So whenever you are using tail recursion, we use an accumulator as the second argument. What is the advantage if you are using tail recursion? We will not get stack out of flow errors, because as I told you, if you are calling same function recursive as the last line, since there is nothing to execute at the last, in stack there will be nothing to store. Okay, so we will never get stack out of flow errors. So that is called as tail recursion. And if you have to implement tail recursion, remember your function has to take a accumulator, right? This is the idea. So in the next video, I will show you an important function in DataView called as reduce, which will use a similar concept to tail recursion. See you in next video.